Right, hi students. Today's video, we'll be doing the homework questions from assignment 2.2, chapter 2, equations and inequalities. Right, let's look at this question here. So you're given a line and then you're given a curve, right? But you're not told if the line definitely intersects the curve. The only information you're given is m is less than 1. So when you're doing questions where you need to explain or prove or show, you can only make use of you can only make use of the information that's given to you. But the information that's not given to you, you cannot make use of it. What do I mean by saying that? Some of you may just assume that the line intersects the curve, and hence you will just be using b squared minus 4ac more than or equal to 0, right? Because when the line intersects the curve, it can intersect at 1 point or 2 points. So we are talking about real roots. So for real roots, b squared minus 4ac is more than or equal to 0. However, you cannot use this information. You cannot use this. You cannot let discriminants to be greater or equal to 0 straight away, because this piece of information is not fixed. It is not what do you call that, a fixed information given in the question. You are just you are asked to explain if the line really intersect the curve. However, there's one piece of information that you definitely can use, and that is you are told that m is less than 1. So whatever information is given to you, a definite information you can use, but if the information it's not definite, then you can't use it in a proving question. Okay, right. So what we're going to do is we're going to call this equation 1, and this let it be equation 2. Right. So the purpose of letting 1 equals to 2 is to form a quadratic equations in terms of x. Right, so the next step is to find the values for b squared minus 4ac. Right, so let's write down the coefficients of x squared, which is m, coefficients of x, which is 6, and the constant is 7. Let's sub into the b squared minus 4ac and see what happened. Alright, so what we're getting here is 36 minus 28m, and you can't actually make any kind of further conclusions from this 36 minus 28m. Right, so however, right, just now we mentioned earlier on that if the information is a definite one, you can actually make use of it, and the definite information given to you is m is less than 1. Right, so what we're going to do is that we're going to multiply both sides with 28, and then multiply both sides with negative 1. And if that's the case, we have to change your inequality sign, and the next thing is to add 36 to it. All right. So why do I do all these steps? It's because I want to get this value here, 36 minus 28m. Right. So if you look at what we get on the right hand side, you will see that 36 minus 28m, regardless of whatever values, or not whatever values, m must be less than 1. When we substitute values of m less than 1, the value for 36 minus 28m the value will be more than 8. Right, and what does more than 8 means? It means it's a value that is more than 0. 8 is more than 0, right? So then what is the conclusions we can make here? Right, the conclusion we can make here is the value for b squared minus 4ac is more than 0. And if the values for b squared minus 4ac is more than 0, we can conclude that the line, so since b squared minus 4ac is more than 0, the line y equals to negative 6x minus 5 intersects the curve. Right, so to summarize what we have just done is that we are not told that the line and the curve will intersect each other. We are supposed to prove it. Hence, you can't use b squared minus 4ac more than or equal to 0 straight away. You can't. Okay, you have to find the values for b squared minus 4ac. However, we can actually make use of this information here, m less than 1, because it's given to you. So information is given to you, you can just use it. Information that is not definite, if you need to show, explain, or to verify, or to whatever, then you will have to find the values of b squared minus 4ac first, and then only at the last steps when you can verify that the value is more than 0, less than 0, equal to 0, then you can make a conclusion whether the line intersects the curve, or the line touches the curve, or the line does not touch the curve at all. Okay. Right, so if you look at question 6, again, this is the questions that you are supposed to show that the roots of the equations given are real for all real values of p. Right, so you are not told that the roots are real. You're supposed to show that it's real. Hence you can't let b squared minus 4ac more than 0 straight away. You can't do that. Okay, it's not the definite information that if it's a definite information, then the questions will be given that the roots of the equations are real. If that is the situation, then you can straight away use b squared minus 4ac more than or equal to 0. Here you cannot, because here you're supposed to show, you're supposed to verify, you're supposed to prove that the roots of the equations are real. So how do you go about doing it? Yeah, we just write down the values of a first, which is the coefficients of x squared, that's 1. B, which is the coefficients of x, here it's p plus 1. Oh, wait. We need to form a quadratic equation first. That means I need to bring all the terms, put it on the left-hand side first. Alright, then I write down the values of a, which is the coefficients of x squared, that's 1. B, that's the coefficients of x, which is p plus 1. Okay, and then of course your constant c. Whatever remaining will be a constant c. I'm going to write it as 2p minus 5. Alright, so as what we mentioned earlier on, we need to find the values for b squared minus 4ac. Alright, we're going to expand this. So this one you can just use your algebraic identities. Right, be careful, because negative 4 times negative 5 will give you positive 20. So if you simplify further, right, this is what you get. So from this expression, this quadratic expression, you can't really tell. You can't really tell whether the value will be more than or equal to 0 or more than 0. You can't really tell. So how are you able to tell, right, that the value, whatever values you substitute in for p, right, the outcome will be more than 0, right? So the only way to do that is to apply completing the square. That means we try to make p squared minus 6p plus 21 into a perfect square. Okay, so right, so how do we complete the square? Take the coefficients of p, which is negative 6, divide by 2, and then you have to take it away. If you've forgotten how to do completing the square, please visit the earliest video I've done. So this one will gives you p minus, okay, negative 6 over 2 is negative 3, so we just simplify it. Simplify negative 6 over 2 to be negative 3. This one you can just use a calculator to work it out. That will gives you a 9, 21 plus 9, it's oh my god, what is that? 30 plus 30. Okay, right, so now we need to do some explanation. Hey, wait. Oh my god, something is wrong with me. It's plus and minus. Okay, plus and 9 minus. So that will be negative 9 plus 21. That will be 12, is it? Plus 12. Okay, plus 12. All right, so we need to do some explanation, right? So we know that, this will always be greater or equal than 0. So if you were to add 12 to both sides, and then that will give you 12. And 12 clearly is more than 0, right? So therefore, at this juncture, at this point, you can say that b squared, the value for b squared minus 4ac, it's more than 0 because 12 definitely is more than 0, right? And if the value that, and since we have verified that the value for b squared minus 4ac is more than 0, we can conclude that the roots of the equation are real for all real values of p. Okay, so now let's look at question 9. Right, you're given a curve, and the curve and the line passes through the point 1, 1. Right, so if you're going to do a simple sketch, I think what they're trying to say is this line and this curve, right? So the line will pass through the point 1, 1. Oh, it may not be like this, right? It could be, okay, wait, it could be in this situation, or it could be this situation, right? Correct. But if you look at part 1, which situation does the question wants you to adopt? Yes, they want you to adopt this one, the second one, because here the information given to you is there is only one point of intersection. You see, so this piece of information is given to you, hence you can use it. So what does one point of intersection means? Means there's two real repeated roots. So what is the concept involving two real repeated roots? If you have two real repeated roots, what would the values of b squared minus 4ac be? Yes, it will be equal to 0. And here you can clearly use b squared minus 4ac equals to 0, because you are told in the question that there is only one point of intersection. So you can use that. All right. But before we use that, let's find a equations in terms of x first. So let's call this equation 1. This one is equation 2. So we let 1 equals to 2. And let's form equations in terms of x. So you will have x squared equals to mx minus m plus 1. So if you bring all the terms to the left hand side, this is what you get. Let's write down the values of a, which is the coefficients of x squared, that's 1. Values of b, coefficients of x, which is negative m. And the remaining one will just be your constant. Alright, okay, so we can just use what we have said earlier on. We can use this piece of information. Right, so you will get m equals to 2. Right, so if m is equals to 2, then there will only be one point of intersection. So that's for part 1. Alright, so for part 2, what can you say about the line with regard to its position to the curve? Okay, so what they're trying to say is if there's only one point of intersection, right? There's only one point of intersection. So what can you say about this line? What do you call this line? What do you call a line when it only touches the curve at one point? Right, what do you call the line when it touches only the circle at one point? Yes, so this line is actually called the tangent line. Alright, so the line with regards to its position to the curve, it's a tangent line. Right, let's look at question 11. It's a rather interesting question. So you're asked to find if there are any values of k such that the curve lies completely above the line y equals to x plus k. So in this case here, we do not know. You see, we do not know if the curve lies completely above the line. We do not know, right? So it's not a fixed information. So hence we cannot use b squared minus 4ac less than 0. A curve lies completely the line. Okay, we have a curve, and then if you look at this line here, the gradient, it's 1, it's a positive value, so your line will look like this. So what we are saying here is that we're not sure if the curve lies completely above the line. So likewise, we cannot use b squared minus 4ac less than 0. Right, so we need to go and find the values for b squared minus 4ac and see what kind of values we get. Okay, right, so what we're going to do is same thing. We're going to call this what's the meaning of same thing, like what we have done earlier on. Call this equation 1, this equation 2, form of equations in terms of x. So we're going to let 1 equals to 2, put everything on the left hand side. Write down the values of a, which is the coefficients of x squared, values of b, coefficients of x, and whatever remaining is a constant c. Alright, so let's go on to find the values for b squared minus 4ac. Okay, so for simplification, I'm going to shift negative k, put it beside 4. It's just like, if you got 2 times 3 times 4, you can just put it as 3 times 4 times 2, or put it as 2 times 4 times 3, right? You will get the same answer, right? So likewise, I'm shifting this negative k to put beside 4, so that I will get positive 4k. Right, then I simplify further. 4k times k will be 4k squared, and 4k times 3 will be 12k. Right, so I end up getting a quadratic expression. Right, so we're going to perform completing the square on it. Right, so to apply completing the square, I need to make coefficients of k squared to be 1. So I need to factorize 4 out. Okay, right, so how do I do it? Right, take the coefficients of k, which is 3, divide by 2, square it, add and minus. Alright, there's a huge square bracket here, so be careful. And then these 3 terms will collapse into k plus 3 over 2 squared. This one, if you use a calculator to work it out, will be 9 over 4. The huge square bracket remains. Multiply the 4 in. 4 times 9 over 4 plus 16. I'm going to continue it here. And that I'll get 4 bracket k plus 3 over 2 squared minus 9 plus 16. Minus 9 plus 16 will give you positive 7. Alright, so let's do some explanation. So 4 bracket k plus 3 over 2 squared will be more than equal than 0. So if you add a 7 to it, it will be more than or equal than 7. Right, which is more than 0. So what we are saying here is the values for b squared minus 4ac, it's more than 0. And if b squared minus 4ac is more than 0, the curve would intersect the line at 2 distinct points, right? Right. So the curve would intersect the line at 2 distinct points. So therefore, if you want the curve to be lying completely above a line, it will not happen, because we just proved it that the curve will intersect the line at 2 distinct points, because the value we get for b squared minus 4ac is more than 0. So hence we conclude that there are no values of k. There are no values of k such that the curve lies completely above the line. Okay? Because the end result we're getting is the value for b squared minus 4ac is a positive value. And the concept involving b squared minus 4ac more than 0 is we should have 2 real and distinct roots. That means the curve would intersect the line at 2 distinct points. So surely that should be that there is no values of k for the curve to be above the line. Right? Okay. Right, so for part 2, since we've already proved in part 1 that in part 1, right, we have proved that the curve and the line will intersect at 2 distinct points, right? So what is the relationship between the curve and the line in part 1? Yeah, we just explained it. So the curve, right, let's erase it. Okay, let's write properly. Right, so the curve will intersect the line in part 1 at 2 distinct points. Yeah, because if you were to recall, in part 1, we have proved that the value for b squared minus 4ac is more than 0. And if the value for b squared minus 4ac is more than 0, it means that we are expecting 2 intersection points. We are expecting 2 real and distinct points. So therefore, the curve will intersect the line in part I at 2 distinct points. That is the relationship between the curve and the line. Right, let's come to the last part of your homework, and that is question 14. Right, so you're given a formula, this formula, that will help you to calculate the cost in thousands of dollars to produce n 100 pairs of shoes. So what does it mean? So I'm just going to give you one example. If I let n equals to 1, if n is equals to 1, that means I'm actually producing 100 pairs of shoes. Let's calculate how much will be the production cost. $1.2 minus 14.4 plus 53.7. You get 40.5. But the value for C is in terms of thousands of dollars. So the actual cost is 40.5 times 1,000. That gives you 40,500. 40.5 times 1,000. Yeah, 40,500. So the actual cost is 40,500 to produce 100 pair of shoes. So one shoe will cost $405. So wouldn't you need to sell it for 1,000 to make money? Right, something like that lah. Okay, so for part 1, right, we need to explain if it's possible or why is it impossible. Why is it impossible to have a cost of productions of $10,000? Okay, so what we're trying to say is that for part 1, all right, if the values for C, it's $10,000, but because C is measured in $1,000, right? So we can't put 10,000. You just put 10. If C is equals to 10, and if C is equals to 1.2 n squared minus 14.4 n, we want to see if there's any intersection point. Right, so we're going to let 1 equals to 2 to form equations in terms of n. So this is something similar to what we have done earlier on, a curve and a line. Right, C equals to n is a line. C equals to 1.2 n squared blah 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 is a curve. So you want to see if this, what is the relationship between this line and the curve. Does it meet, or it does not meet, or it meet at 1 point or meet at 2 points? This is what we're trying to find out. Okay, so the concept involving here is if it meet, does not meet, meet at 1 point, meet at 2 points, is to find the values of b squared minus 4ac. Alright, so we're going to use a calculator to work it out. And you get negative 2.4. So what can you say about this value negative 2.4? Right, it's less than 0. So if you get the values of b squared minus 4ac to be less than 0, what kind of conclusions can you make? Yeah, the curve will not meet the line. So that there is no real roots. So if there's no real roots, then of course it is impossible to have a cost of production of $10,000, right? Because there's no intersection point at all, right? So therefore, okay, not therefore, since alright, since b squared minus 4ac is less than 0, it is impossible to have a cost of productions of $10,000. Okay. Right, let's do part 2. Part 2, we asked to explain why it is possible for the cost of production to reach $80,000. Alright, so the steps involved is the same as in part 1. We're going to let C equals to 80 and then C equals to 1.2 n squared minus 14.4 n. So likewise, we're going to form equations in terms of n. Alright, and we're going to solve this quadratic equation by using quadratic formula and see if we can get some values for n. So the values of b is negative 14.4. Okay, negative 26.3, my god, over 2 times 1.2. Alright, so if we were to work it out, right, you will have 13.6 as one answer. Second answer is negative 1.61. Alright, so what does it mean? it means that they are actually 2 points. When we solve this curve and this line, they actually intersects at 2 points, right? So therefore, it is possible. The values for n, there is a positive values. N represent the number of running shoes. So it's possible because we do have a positive value for n. Of course, the other value is not valid, the negative 1.61. If you manage to get both negative, then of course it's not possible at all. Right, but if you manage to get one of them positive, then it is possible. It is possible that there is a production cost of 80,000. So since there is a value for n, there is a positive value for n, right? Therefore, it is possible for the production cost to reach 80,000. Right, let's come to part 3 of question 14. All right, let's look at the questions. So you asked to find the range of values of x. So what does this tell you? That means there's no fixed answer for x. So x is not something like x equals to 4, x equals to 5. No, it's actually inequality, that x more than something or x less than something. And the cost of production is always more than x $1,000. So what is the symbol that represents your cost of production? So it's the letter C. So what we are saying in part 3 is you want this guy C to be always more than x, right? And we have a formula to calculate C, right? So C is 1.2 n squared minus 14.4 n plus 53.7. So what we are saying is that I want this guy 1.2 n squared minus 14.4 n plus 53.7 to be more than x. Okay, now you are given an equation that it's in terms of n now, n, not x. Previously, what we have been doing is all in terms of x, right? But if you look at this carefully, you're actually given the equations in terms of n. And if you were to draw your curve, what is on the x-axis is the letter n, and what is on the y-axis is the letter c. Okay, so this one you must keep that in mind, be clear about it. So therefore, if I were to bring x to the left hand side, your x here becomes a constant, right? It's a constant. Okay, so if you were to sketch the curve, what we are saying that we want a curve such that the values of c, right, it's always more than 0. So the c is just like your letter y that you always deal with. So if you want your y to be always positive or the c to be always positive, means the curve is entirely above your n-axis. Okay, the curve is entirely above your n-axis. And what is the concept here? It means that there's no real root. And therefore, the values of b squared minus 4ac definitely will be less than 0. Okay, so the first thing is to write down the coefficients of n squared, which is 1.2, coefficients of n, which is negative 14.4, and the remaining is just a constant c. So we're going to substitute into your b squared minus 4ac less than 0. And then we see what happened. So we can use a calculator to work it out. 4 times 1.2 is 4.8. Okay, due to the lack of space, I'm just going to simplify it. You get a negative 50.4. If you were to bring it over, it will be positive 50.4. To find x, you just take 50.4 divided by 4.8. You don't have to change the inequality sign because you are dividing it with a positive number, and you get 10.5. Right, so we're saying that if the values of x is less than 10.5, then it is possible that the cost of production is always more than x $1,000. That means, what is one possible values of x that's less than 10.5? 9. So we are saying that it's possible to have $9,000, more than $9,000. Sorry, it's always more than $9,000. If you want it, if you want your cost of productions to be $9,000, then your x will be 9, right? Right. So we found that x is less than 10.5. Okay, but that's not the answer yet. Why is that not the answer? Because let's look at what x represents. X represents the cost in $1,000. We're talking about x. It's a currency. It's money. So if you have x less than 10.5, if we draw the number line, it means that it's possible to also have negative value, right? If your answer is x less than 10.5, then it's possible to have x -2, -1. Then the next question you have to ask yourself is it possible, if you're talking about currency, can you have negative number for money? Is it possible? It's not quite possible, right? So therefore, the range of values of x will be strictly more than 0. It has to be a positive value and less than 10.5. So that would be your answer. Okay, right. So that ends the explanations for the assignment 2.2. Please make an effort to look at its solution carefully, understand it, and then try it on your own.